and the voltmeters. Assalamualaikum and welcome back to my topical video lesson. In this video, I'm going to teach you a topic from Science Form 2, topic number 7.2, flow of electric current in the series and parallel circuit. Pop quiz question time! What is the most suitable electrical circuit wiring system to be used in a house? Let's begin the first part, electric circuit component. Electrical circuit is made up of the combination of several numbers of electrical components connected in certain ways. The diagram of an electrical circuit is drawn by using symbols. And electrical components also can be represented by using symbols. This is a bulb symbol, a switch symbol, a dry cell symbol, ammeter, voltmeter, resistor, galvanometer, variable resistor, or the rheostat. For example, if we have an electrical circuit arranged like this, we can draw the schematic diagram of this electrical circuit like this. An electrical circuit is said as complete when all the electrical components connected allows current to flow through it.
This is complete circuit. This is incomplete circuit. Complete circuit. Incomplete circuit. In most of the time, complete circuit is also mentioned as closed circuit, while the incomplete circuit is also mentioned as open circuit.
There are two types of electrical circuit, the series circuit and the parallel circuit. A series circuit is a type of circuit when all of the electrical components is connected one after the other in one path, and the current is only allowed to pass through one path. This is the example of series circuit. In a series circuit, the value of current at any point along the path of the circuit is the same. For example, the value of current at point A is equal to the value of current at point B and also equal to the value of current at point C. However, for the voltage, the total value of voltage across each component along the path of the circuit is equal to the amount of voltage supplied by the dry cell or the battery for the circuit. For example, the voltage across bulb A when added to the voltage across bulb B is equal to the voltage value supplied by the battery. The effective resistance is the total amount of resistance of each of the electrical components in the circuit. To find the effective resistance for the circuit, you must add the value of resistance in all the components in the circuit. For example, resistance in bulb A add to the resistance value of bulb B. So this means that the more electrical components connected in the circuit, the higher the effective resistance in the circuit. When the value of effective resistance is big, the amount of current flowing in the circuit will reduce as a consequence. For example, if we connect many bulbs in series in a circuit, the brightness of the bulb will reduce. This schematic diagram here shows how electrical components are connected in series and also how ammeters and the voltmeters are connected for the currents and the voltage measurements respectively. There are advantages and disadvantages when the electrical components are connected in series. The amount of current flows in each of the electrical components in a series circuit is not affected by the amount of resistance in the circuit. All electrical components in a series circuit are controlled by one switch, and it also saves on the use of wire. If one component blows or spoils, all of the electrical components in the circuit will also not functioning. When there are too many electrical components connected in series in the circuit, the amount of resistance will increase and the value of current flowing in the circuit will reduce. Each of the electrical components cannot be controlled individually.
Oh my God! Wow!
Now let's move on to parallel circuit. A circuit is said as a parallel circuit when there are more than one path for the current to flow. The electrical components can be connected on different paths to make a parallel circuit. The diagram shows how components can be connected parallel in a parallel circuit. For the parallel circuit, the total amount of current in the circuit is equal to the sum of the current flowing in each of the electrical components in the circuit connected parallel on different paths. For example, when the value of current flowing in bulb A is added to the value of current flowing in bulb B that are connected parallel in the circuit, the value is equal to the total amount of current in the circuit. However, for voltage, the value of voltage across each of the components connected parallel in a circuit are the same to the value of voltage from the power supply. For example, the value of voltage across bulb A is equal to the value of voltage across bulb B, which is also equal to the voltage supplied by the battery. Next is the effective resistance. For a parallel circuit, the reciprocal of effective resistance in the circuit is equal to the sum of the reciprocal of resistance in each of the electrical components in the circuit. What is reciprocal? What is reciprocal? Reciprocal is the inverse value or the quantity when 1 is divided by a number. So the value of effective resistance in a parallel circuit is always less than the value of resistance in any of the electrical component connected in parallel in the circuit. And the formula for effective resistance in a parallel circuit is a little bit complicated. It is stated as 1 over effective resistance is equal to 1 over resistance in bulb A plus 1 over resistance in bulb B. Or if you are comfortable enough to use the term reciprocal, you can say it as reciprocal of effective resistance is equal to the sum of reciprocal of resistance in all of the electrical components in the circuit. of the electrical components can be controlled individually. If one component fails, the other components in the other path of a parallel circuit can still functioning. The increase in the number of electrical components connected parallel in a parallel circuit will not jeopardize the performance of the electrical components in the circuit. The voltage across each electrical components in a parallel circuit is the same as the voltage supplied. It uses too many wires. More electrical power is used when too many electrical components are connected in a parallel circuit. It simply means higher electrical bills. Here are the differences comparison between series circuit and parallel circuit. Use your analytical thinking skills to answer my second pop quiz question. From the comparison between series and parallel circuit, state two similarities between the series and the parallel circuit. You have the formula of effective resistance for series circuit. Effective resistance equal to resistance in bulb 1 plus resistance in bulb 2. Since the resistance in bulb 1 and resistance in bulb 2, the values are given as 2 ohms and 5 ohms respectively, then you only need to directly add these two. 2 ohms plus 5 ohms, and the value of effective resistance is 7 ohms. From the Ohm's law, which is V equals to IR, V for the voltage, I for the current, and R for the resistance. From the previous question, the value of effective resistance is known as 7 ohms, and the voltage value also given 7 volt from the 3 volts. So you just need to substitute the value in the formula. Let's say V is 3 equals to I is the value to be calculated, and R is 7. So now to cancel the 7 here, we divide by 7 on each side of the equal sign. So 7 and 7 cancel. Then we have 3 over 7 equal to the value of current. And we can use calculator here. 3 divided by 7, it's 0.428. 0.428 ampere. And for this question again, by using the Ohm's law, V equals to IR, where V is voltage, I is current, and R for the resistance. The voltage flow in a bulb A
is equal to current flowing in bulb A times resistance in bulb A. We know the value of resistance in bulb A as 2 ohms, and the current calculated from the second question was 0.43 ampere. We just substitute the value I and R. (0.43 ampere times 2 ohms, and the number will be 0.86 volt. The voltage across A is 0.86 volts. The formula for effective resistance in a parallel circuit is reciprocal of effective resistance equal to reciprocal of resistance in bulb A plus reciprocal of resistance in bulb B. We know the value of resistance in A and B are 2 ohms and 5 ohms respectively. Now we substitute the value 1 over 2 ohms plus 1 over 5 ohms equal to 1 over effective resistance. So from here, we do the mathematics. This is times 5, this is times 2, times 2. So the value now 5 over 10 plus 2 over 10. 5 plus 2, 7 over 10 equal to 1 over effective resistance. So to find the effective resistance, we inverse this reciprocal. We bring the R above and 1 down. It means this side also need to be inverse. 10 bring up and 7 bring down. So the answer will be 1.43 ohms. That is the effective resistance. To find the total current in the circuit, we use the Ohm's law. V equals to IR. V for the voltage, I for current, R for the effective resistance. So we know the voltage in the circuit as 3 volt and the effective resistance as 1.43 ohms. We substitute the value 3 equal to the I is unknown and R is 1.43 ohms. So to cancel this value, to cancel 1.43 ohms, we divide both sides with 1.43 ohms. So this part cancels, and we left with I equal to 3 volt over 1.43 ohms, and the answer is 2.10 ampere. So for question C, we know that the voltage across each electrical components in parallel circuit is always the same. Since we already know the voltage supply from the power supply is 3 volt, the answer for the voltage flowing through bulb A
is just equal to the power supply, which is 3 volt. So boys and girls, that's all about series and parallel circuit for this topical video lesson. I hope this video helps you to understand better. And if you haven't subscribed, please subscribe my channel and click the like button, and please share the video with your friends. And I hope to see you again in my next video. Good night.